Today is Monday, January 28th, and we are starting a brand new module today, Module 4, okay? Now, Module 4 starts out a little bit differently because Module 4.1, Module 4, Lesson 1, is kind of a standalone lesson. It doesn't really have that much to do with tomorrow's lesson, okay? Today's lesson is kind of all by itself, but it's very important because it's teaching you about something that will come up again on things like your middle school math placement test, on things like your CASP test. So it's important to really understand today's concept as well, okay? Today your learning goal says I can analyze data, I can make sense of data by making and reading a line plot. Your problem of the day has an example of a line plot right here, but actually we're not going to talk about your problem of the day quite yet. On problem set number 1, it says to first, please estimate, don't use any rulers, don't use any measuring tools, estimate the length of your pencil strip, that's that piece of paper now, to the nearest inch. If you know about an inch is about this big, about how many inches do you think your pencil strip is? Go ahead and write that number. Like for mine, I think maybe it's 4 inches. So I'm going to write it on the line. Step 2 says, using a ruler, which I just gave you, you measure your pencil strip to the nearest ½ inch. Is the ruler in your workbook a real ruler? No. So you can't use that one to measure it. You have to use a ruler to measure it to the nearest ½ inch. Eyes up at the board for one moment. Since I know my pencil strip was 5 inches, I'm going to make a nice, neat X exactly where it says 5 inches. Go ahead and make your X for your pencil strip. What we're going to do now is we're going to use all of our pencil strip data to make a line plot. So when I call your name, you're going to tell me your measurement. And we are all going to add an X above on the ruler. So Rashid, how long was your pencil?
5.5 inches.
5.5. So we're going to put an X right where it says 5.5. Let's all do that. Geffen, how about you?
5.5.
5.5. Geffen's was also 5.5. We already have one X where it says 5.5, so we're going to put Geffen's X right above Rashid's X on the 5.5 space on our ruler. Go ahead and do that. Kim, how long was yours? 3.5. Okay, so let's go ahead and put an X on 3.5. I'm going to continue calling your names, and you're going to shout out your number, and we're all going to put the X. Now we've made a line plot. This is called a line plot. A line plot is a graph where you have a number line at the bottom, okay? One number line. And then your data gets stacked on top of that line. Okay, in this case, the number line is a ruler. This is different than a 2-coordinate grid, right? 2-coordinate graph, because 2-coordinate graphs have an x-axis and a y-axis. This line plots only have one number line at the bottom, and then all the data gets stacked on top. Now, looking at this, we can analyze it. We can use this to help us make sense of data. For example, what is our most common pencil length here? 5 inches. Good. What is our shortest pencil currently being used in the classroom? 2.5 inches. What's our longest pencil currently being used in the classroom? 7. So what's the difference between the shortest pencil and the longest pencil? 7 minus 2.5 is, so what's 7 minus 2? Minus 1/2. 4.5 inches. We have a 4.5 inch pencil range currently being used in room 50. This time, do you guys see how the number line at the bottom isn't just divided into halves and now has 5.25, 5.5, 5 3/4, and 6. It's divided into fourths now. Do you see that? All right, very good. Let's go around the room. I'm going to call on you again, and this time tell me your new pencil length. It's still the same length. Did the length of your pencil strip change? But then why would there be a new measurement? Is it more precise now or less precise? More precise. Very good. So if it's more precise, how do you think it's going to affect our line plot? Do you think we're still going to have as many stacked up on 5? No, because some of those 5s might now be 5 1/4 or 4 3/4, right? So we should see things more spread out. Let's see if that's the case. Isn't your data for number 3 the same as your data for number 2? Did anyone change the length of their pencil strips? Or is it still the same pencil strips? But we measured it in a different way, huh? Now we measured it to the nearest 1/4 of an inch instead of the nearest ½ inch. So even though 5 still has the most, did it have as many as it did in number 2? No. Your data was more spread out because before, all these X's at 5 1/4, where would they have been? Either on 5 or 5.5, right? So do you see how your data is more spread out now? for question 4, it now tells you to measure it to the nearest 1/8 of an inch. We're not going to do that right now. Let me ask you a question. If we were to do this and do the exact same process and make the line plot, how do you think the data would look? How do you think it would look? Even more spread out. There wouldn't be nearly as many tall towers of X's because the measurements are getting more and more precise. See how that works? Okay, now let's take a look at our problem. Our problem today told us that this is a line plot, okay? And it shows how tall in inches 10 bean plants are growing during their second week of their growth, okay? Now, we can see, how many X's do you expect to see if there are 10 bean plants? 10, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of those X's represents one bean, okay? Now, looking at this line plot, question A, Sawyer, says, what is the measurement of the shortest plant? Can you come on up? Come on up. Point to one of the X's, or point to an X that represents one of the shortest bean plants. Good. Is that the only one he could have pointed to? That's the other one. Very good. And so, don't run away, don't worry. Okay, what is the question asks, what is the measurement of the shortest plant? 1
and 3/4.
Because this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, or 1/4, 1/2, and 3/4. So the shortest plant, the line plot shows that it is 1 3/4 inches. Good, now you can sit down. If you didn't write that down yet, write that down. This is an example of how you can use a line plot and analyze it to get some data, to understand the data. The question's asking now, number 2, how many plants measure exactly 2.5 inches? Okay, Radna, come on down. Can you point to the X or X's that show the plants that are 2.5 inches? She's pointing to these ones right here. Very good. So how many plants measure 2.5 inches? 2 plants. Very good. Now you can go. Again, we can use the data from the line plot to help us answer questions about the data. Okay, good. What is the measurement of the tallest plant? All right. Let's call on Niv to come down. Can you point to the X that represents the tallest plant that we have here? If you see it, go ahead and write down the measurement. Okay, very good. He's pointing over here. What is the measurement of that? 2 and? 2 and 7/8 miles? Oh, inches. Okay, let's write that down. 2 and 7/8 inches. Thank you, Niv. Okay, what is the difference between the longest and the shortest measurement? So we know the longest is this one, 2 and 7/8. What's the shortest again? 1 and 3/4 or 6/8. Good. So in order to find the difference, we have to do 2 and 7/8 minus 1 and 6/8. What's 2 minus 1? 1. If I have 7/8 and I take away 6/8, how many do I have left? 1/8. So the difference is 1 and 1/8 inches. Again, we can use what we see in the data, in the line plot, to help us answer questions about the data.